All right, guys, welcome to this page of the notes. Again, what we're doing is we're graphing rational functions, and really right now we're just getting some practice finding x-intercepts, vertical asymptotes, horizontal asymptotes, and putting those pieces of the puzzle together on our coordinate plane. So let's go ahead and jump right into this. We know, starting us off, in order to find the x-intercepts, I'll set the numerator equal to 0. Well, my numerator, if you look at the function above, is an x squared minus x minus 6. Well, this is a quadratic, and like I told you, we've been doing in all of the sections so far in this chapter, you need to know how to factor. All that factoring you did back in chapter 4 and chapter 5 with quadratics and polynomials, it's all coming back here in this chapter. You need to know how to factor, and this is one of those instances. Right here I have a quadratic. I know it's quadratic because the x is squared, and it's a general trinomial. I know it's a general trinomial because 6 is not a perfect square, so we'll need to factor it as a general trinomial. Here's what I'm hoping. It's just going to nicely factor into two binomials. Let's find out. The easy bit, two things that multiply to an x squared, well, that's an x and an x. The slightly trickier bit, two numbers that multiply to a negative 6, sum to a negative 1. That would be a minus 3 and a plus 2. Now, zero product property lets me set both of those equal to 0, split them up, and solve them each. So I have x minus 3 is equal to 0, which means x is equal to 3. I have x plus 2 is equal to 0, which means x is equal to negative 2. Again, remember what you have just found. You have just found, because y is 0, x-intercepts. I have two of them, and that's okay. It can happen. You could have multiple x-intercepts for these rational functions. In this case, we do. We're going to cross the x-axis twice. We'll cross at x equals 3 and x equals 2. Perfect. Let's keep going. Vertical asymptotes. Well, I know vertical asymptotes are going to be when the denominator is equal to 0. Our denominator is x plus 1. So x plus 1 is equal to 0, which means x equals negative 1. And so I have a vertical asymptote at x equals negative 1. That was easy. Horizontal asymptotes. Well, it depends on the degree. What is the degree of the top? Well, actually, I already put it in descending order for you. The largest power is the x squared, so the degree is 2. In the denominator, it also is in descending order with the x to the first power being first, and since that's the largest power, that's also my degree. Once again, we see that the degree of the top is greater than the degree of the bottom, and so we have rule number 1. I promise you the other rules do show up. I'm just saving those rules for when we look at the problems more like the ones I'll actually ask you to do on a quiz or a test. But the other rule, I know we've had rule number 1 3 times in a row now, but the other rules will show up. I promise they will. This is the trickiest one, right? Because remember, rule number 1 means you don't have a horizontal asymptote. You actually have a slanted asymptote. That makes these problems a little bit trickier, and so I'm using this one more than the other ones because we want to get lots of practice. How do we find those slanted asymptotes? But we'll talk about that in just a moment. What that means is we have no horizontal asymptote. All right, here we go. Head back up here to my graph, and here's what we found. We found that I have x-intercepts at positive 3, 1, 2, 3, and negative 2, negative 2. We also found that we have a vertical asymptote at negative 1. So there's negative 1 right there. And again, if you were to use a graphing calculator, what you would find is that this guy runs down through here like this, and right up through here like this. And you can kind of see where that slanted asymptote will probably wind up running. And it does, it runs right through there. And as we move on to other problems here in this set of notes, we'll show you how you find that slanted asymptote. You will need to be able to find those slanted asymptotes, and I'll show you how to do that in the next couple of pages of the notes. In fact, actually, on the next page of the notes, what we'll do is we'll talk about those slanted asymptotes, how you go about finding them, and also, if you remember back to the front page of the notes, the second objective had not only oblique asymptotes, slanted asymptotes, but what we call point discontinuity, which is actually going to be a hole in the graph. So on the next page of the notes, we'll talk about both of those. I'm really excited to show you how it works. I'll meet you guys there.